So in problem 20, we have to find the total capacitance of a parallel plate capacitor that is only partially filled with the dielectric. You start out by splitting the capacitor into three parts, one to the left, one to the right, and the section in the middle contains the dielectric. You treat these three as three capacitors in parallel because the change in voltage across the portion of this capacitor with the dielectric is different from the change in voltage across the same portion of the capacitor without a dielectric. However, the total change in voltage from one plate to the other remains the same for all three sections. So now we've named the three sections, 1, 2, and 3, and next you have to break section 2 into three portions in series, which I've named A, B, and C. And just to reiterate again, sections 1, 2, and 3 are in parallel, whereas sections A, B, and C are in series. So capacitance is epsilon naught times the area divided by distance. You can find the area of the entire capacitor because you have the diameter, and likewise for the dielectric. To find the area of section 1 and 3, you find the area of the capacitor not covered by the dielectric, and then you divide this in half. And now you can find the capacitance for 1 and 3. So next you want to find the capacitance for A, B, and C. Distance for B is given, and you can find the distance for A and C by subtracting the dielectric's distance from the total distance, and then dividing that in half. From there, you can calculate the capacitance of A and C. For section B, the capacitance is multiplied by the dielectric constant, which in this case is 2. Now you can find the capacitance of section 2. Because A, B, and C are in series, you have to use their inverse to find the capacitance. Now that you have the capacitance of section 1, 2, and 3, you can find the equivalent capacitance of the capacitor. Because the sections are in parallel, you just add their respective capacitance together, and then you get 1.8 times 10 to the negative 9th.